So we all use software and computers in our daily lives. Well, at least most of us. Do we know what software engineers and computer scientists do for their job? I'd say no. But me, myself, as a computer scientist at the university, know what they do. So that's what I'm going to be explaining to you. So what does a software engineer actually do? So software engineers observe problems, craft solutions, and test and implement those solutions. So first, they observe problems. Usually, they're paid to do this. People like me who work at the university, we pay the university to actually give us problems to do it for practice, but most engineers are paid in the real world. And many businesses use engineers. As you can see in the top left picture, that's an example of somebody working on a coding problem. And according to the U.S. Bureau of Labor Statistics website, bsl.gov, software engineers actually comprise 1.7 billion jobs in the United States. But research is also done a lot by software engineers as well, academic research and other funded research, as you can see in the bottom right picture. And according to Career Cornerstone Center on their website, careercornerstone.org, software engineers actually improve software in research settings. So after finding this problem, observing this problem, software engineers have to create a solution. That's their whole job, engineering a solution. So first, they use diagrams such as ER on the left and class diagrams. There's a lot of other types of diagrams, but these diagrams help engineers think about ideas logically, putting your ideas together and linking them up. And then they take these ideas and they convert it to what's called pseudocode, which are the small instructions that comprise an algorithm. And it's mostly a mix of English and computer science talk. And this helps engineers translate their thoughts to a computer. According to geeksforgeeks.com, which is a popular programming website, in their article, How to Write Pseudocode, they say that pseudocode can actually make it easier for a programmer to switch between a flowchart and actual code. It's sort of the middle step. So after designing this solution, you have to implement it. You can't just say, hey, I made an algorithm. You actually have to code it. That's part of the software engineer's job. So they'll take the pseudocode, as you can see down here, and they will actually convert it to real code, which is the top left is an example of some real code. It can look kind of like a foreign language because it basically is. And there's just basically bite-sized pieces of code that come from your pseudocode. Then after it's written, it actually undergoes extreme testing. And there's whole fields of computer science dedicated to testing for safety and the convenience of the end user. And we can all see the importance of this as of the recent news of CrowdStrike, where a whole bunch of systems of Microsoft went down, including airport systems. Things around the world shut down because of it. And according to the Institute of Electrical and Electronics Engineers, or IEEE, on their website computer.org, in their article, The Importance of Software Testing, they say that testing software before launch actually improves the quality and ensures the program runs correctly and securely for the end user. So in conclusion, software engineers see problems, they logically think about how to solve them, and then they convert those thoughts into actual code, and then they test them. So hopefully you've gained some insight into what a software engineer actually does in their day-to-day life, and how they are the foundation of all the software around the world. It's kind of crazy to think about. All the software is a foundation by computer scientists and software engineers.